All right, so in this video, we're looking at where a function and its inverse are being composed. And so just as a reminder, the sine function has to be restricted, right? So that the function is actually um, invertible. And so we normally restrict our domain to be between minus pi over 2 and pi over 2, so that the range is always between plus or minus 1. And then the cosine is restricted to be between 0 and pi, right? Oops, minus 1 to 1. And so this means that if you invert it, right, what's the inverse, what's the domain and range of the inverse sine? You just flip those, right? So the input to the inverse sine are numbers between minus 1 and 1. The output are angles between minus pi over 2 and pi over 2. Similarly, for cosine here, we have our input. Oops, sorry about that. Inputs are numbers between plus or minus 1. Outputs are angles between 0 and pi. Good. So when we talk about things like, well, let's just go ahead and do it. So I'm looking at this handout. This is our extra practice trigonometry handout, and I'm looking at number 6 now. But the answers that we get for 6 are similar to what we're going to get for 7. Okay. So let's take a look. So number 6. 6a. Compute the inverse sine of the sine of pi. All right. So the way I want to think about this is I want to think about the sine of theta, sine of pi is going to be equal to what? It's the y coordinate that we're over here, right? Oh, am I doing the right way? Yes. So, so the sine of pi is over here. And so the sine of pi, or you could also look at it this way too, right? Oh, that's the cosine, of course. I better pay attention to what I'm doing here. So what's the sine of pi? Sine of pi is 0. So you could think of this as the inverse sine of 0 then. And what's the inverse sine of 0? That's the angle whose sine is 0. And so that's equal to 0. And so notice that in this case, the inverse sine of the sine of an x equals x, but that's only for angles if x is an angle between negative pi over 2 and pi over 2. Notice that when I put in pi, I got a 0 out. And so only if x is in the right domain. So the upshot is sometimes we have to do a little intermediate step. Okay, let's try number B, or part B, inverse sine of 1. Oops, sorry about that. That's the sine of the inverse sine of 3 over 5. Okay, now this is in the domain, right? And so this is going to be this thing here is going to be theta, where the sine of theta is equal to 3/5, right? So the answer is 3/5. The function undoes itself. We're in the right domain area here. And so the answer is just, yeah, that one was no problem. How about the tangent or inverse tangent of the tangent of pi over 4? Remember, for tangent, our restriction is that x must be between minus pi over 2 and pi over 2. And notice that it does not equal pi over 2 or negative pi over 2. And then the output is all reals. And so if you invert the tangent, the x is all reals, but the y, only the output of the inverse tangent, is just between minus pi over 2 and pi over 2. Good. So pi over 4 is inside of our domain here, and so this is just going to be pi over 4 because it's a function composed with its inverse. We're composing the inverse with the original function, and that's equal to x when x is in the right domain, and in this case it is. Good. And then finally, what happens if it's not? Well, this is the angle theta, and so oops, sorry, that's not the angle, that's an output. What is the tangent of pi? So this is 0, pi over 2, pi. So the tangent of pi is equal to 0. And so the inverse so this is equal to the inverse tangent of 0, and that's equal to 0. Now I knew I needed to do this. Why? Because my outputs need to be between plus or minus 1 pi over 2, and pi is outside this interval, or this interval if you want. And so therefore I had to be a little bit careful with my answer. So I just adjusted this interval to be the same as this interval. In other words, I took tangent of pi and I computed it to be 0. And so now if I compute the inverse tangent of 0, I get 0. Good. So yeah, there were a few complications for number 6, but not too bad. Number 7. So let's take the tangent of the inverse sine of x. The way to do these problems is to think about inverse sine of x as being an angle measure theta. So we know then that the sine of theta must be x, or x over 1. And so this actually defines a triangle. This defines a triangle, a right triangle, whose angle is theta. And so if we have opposite over adjacent, opposite over hypotenuse as x over 1, then the length of the third side would be 1 minus the square root of 1 minus x squared. Okay, and so now what we're looking for is the tangent of theta. And tangent is going to be opposite over adjacent, and so that's just going to be x over the square root of 1 minus x squared. And that is my answer. Good. So that was 7a. Let's try 7b now. So for 7b, we have the cosine of the inverse tangent of x. We want to simplify that. And again, the way to think about this is that this inverse tangent is an angle measure theta, such that the tangent of theta is equal to x over 1. So for tangent, this is opposite over adjacent, right? And so this defines a triangle with angle. So I'm putting the angle here, but you could put the angle up here if you wanted. Opposite side, adjacent side. So this side would be Pythagorean theorem, square root of 1 squared plus x squared. Good. So then we want the cosine of theta, right? That's the cosine of theta. So cosine of theta, of course, is adjacent over hypotenuse. Good. Oops. I'm getting sloppy there. And so this is our answer. 7c. We have the secant of the inverse sine of x. You see how these are going? This is theta, such that sine of theta is equal to x over 1, opposite over hypotenuse. Theta opposite hypotenuse, square root of 1 minus x squared is the third side. Secant of theta is what I want, but secant of theta is 1 over cosine theta, and cosine of theta is adjacent over hypotenuse, right? So that's 1 over the square root of 1 minus x squared. Well, I better be careful there. This is the cosine of, yes, that's right. I was going to say the cosine of theta is 1 over this It's not 1 over the square root. It's adjacent over hypotenuse, right? Good. So that turns out, I think I've got the right one there. 7d tangent of the inverse secant of x. And so this means our theta now is coming out of the secant. Secant theta is equal to x over 1. So that means cosine of theta is 1 over x. And so that's adjacent over hypotenuse, right? Adjacent hypotenuse. So that one's going to be what? X squared minus 1. Good. And so we want the tangent of that, which is opposite over adjacent. And so the answer is the square root of x squared minus 1. Good. If you were able to follow those up to D, I think we're pretty good. I think I will leave parts E and F are optional. Give them a try. The only reason I'm leaving those as optional is because we require an extra an extra trig identity. And so if you were able to do the other ones without that trig identity, then you're doing good. Okay, so I think we're out of time for the extra practice. I think we finally made it through all of them. All right. So if you're still having trouble with the trig, try looking back at Appendix D again, and there's some more practice problems like this in that section. Okay, or of course you can come talk to me. All right, I'll talk to you later.